So in this particular problem, we want to identify what is the smallest average rate of change. Remember, when we find the average rate of change, we're going to find the change in y divided by the change in x. Let me press pause, and I'm going to test where x equals 1 to x equals 2. So let me demonstrate part A for us. So how I would do this is that this is not an ordered pair. This is a range in x values. And so we're going to figure out the average rate of change from 1 to 2. So including 1, including 2. So 1 goes with a distance of 53 miles, and 2 goes with a distance of 115 miles. This is your x sub 1, your y sub 1. It's your first order pair, your x sub 2, y sub 2, second order pair. Now this relates back to how you figured out rate of change with linear functions. And so what we're going to do is we're going to take y sub 2 minus y sub 1. The change of y is always in the numerator, change of x is always in the denominator, and we end up with 62. I would do the same for A, do the same for B, for C, and for D. Now let me demonstrate what the correct answer is. All right, so I would do the same for part B, but instead of going from 1 to 2, I would go 2 to 4, and then 4 to 7, and 7 to 8. And after I had found out the rate of change for each one of these intervals, I would just select the smallest one. I'm going to demonstrate what the correct answer is. I took time on my own to do B and D, and I found out that C had the smallest rate of change. So what does 4? 4 is going to correspond to 240. 7 is going to correspond to 410. So this is my y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I end up with 170 divided by 3. I come off to the side. Okay, 3 goes into 17 5 times. Remember, there's no calculator here. 3 goes into 20. It can go in 6 times. And then we just have this repeating 56.6. And if you did each one of these options, you would see that C produces the smallest average rate of change.